Okay, one of the first thing I want to talk about here is something everybody needs to know. I'm going to start trying to hit you guys with a few no-start bugs, so I can see if you can figure out what's wrong with one. I mentioned that to Garrett earlier. But this guy sent me an email, and he says, I have an F-150 1995 model, cranks but won't start. When starting fluid is used, engine starts. No power to the fuel pumps in the tanks. It ran fine for over 40 miles, stopped for fuel, and wouldn't start. It's a 5.8 with automatic transmission, dual tanks, two-wheel drive. Have not used the truck for over 2 years, but the truck was started monthly and allowed to warm to running temperature. Noticed that engine at idle and neutral was running rough, but no miss at speeds. Plan to change drivetrain control module. Now he hasn't. The only troubleshooting that he's done is he's shot a little starting fluid in there. So you know, what do you know? If you spray some, he says when starting fluid is used, the engine starts. All right.
It'll run when they get fuel.
Okay, so basically we know that it's in time. We know that we got good ignition system operation and all that. We're not getting any fuel. No power to the pumps in the tanks. Now he didn't tell us how he knows there's no power to the pumps in the tanks. He just said there's no power to the pumps in the tanks. He may be assuming that there's no power to the pump in the tank, right? You got that? What would you tell him? Now imagine him asking you. The information that you have is the information I had. It starts with starting fluid. It ran fine, stopped for fuel, wouldn't start.
Either the fuel pump or a relay or a fuse or something.
Now think about it. He's got 2 tanks and 2 fuel pumps.
Oh, you got 2 tanks.
That's right. And he's got a switch on the dash that goes front and rear.
That little switch between the two, maybe.
That is actually, this one does not have an electric tank switching valve. The switch on the dash on this 95 model, and that's something that was a good point. The earlier ones used to have a switching valve that had the electric part of the switching from front to back pumps was done on the older ones down there where he's talking about. However, on this one, it's got a little thing, kind of a reservoir deal with a diaphragm in there. And when you turn off the front pump and turn on the back pump, that little diaphragm, that fuel pressure coming in there acts on that diaphragm and it makes the switch. So the diaphragm itself in there, it can transfer fuel from one tank to the other if that little diaphragm ruptures. It's well, I say little diaphragm, it's probably about 4 inches in diameter.
Is that like a little float?
Not really a float. It's basically got a diaphragm about that big around that's mounted like this, and it's through the middle of it is hooked to a little valve.
Works like an actuator.
Sort of, but when you got pressure on the bottom of it, it moves it up, and when pressure comes in on the top of it, it clicks it down.
Well, what if it's stuck?
Yeah, it could be stuck, but we ain't got no. Well, he's still going to have pressure. I mean, he's still going to have pumps running. You know, the pump's going to be running. But if it's typically, you won't have it sticking. The only trouble that thing typically gives is whenever you've got both tanks full, it'll start transferring fuel from one tank to the other through that little valve, and it'll make the tank that you're not using run over. You get me? I mean, because the return part of it, you know, it'll either go through the diaphragm or the return doesn't switch and all that. I mean, that's a valving problem, and that won't keep the pumps from running. Okay, tell me what else. Tell me what you're going to tell him. He needs some information to try to get this thing going. And so, how are you going to tell him to start out the troubleshooting? What's the first thing you're going to tell him to do? And you got to realize this guy right here, he sprayed starting fluid in it. He says the pumps aren't running. We don't know how he knows that, other than the fact that maybe he's not hearing them.
See if any gas in there first.
Yeah. Well, he got 2 tanks now.
Yeah. Well, they're not empty though, right?
Mm-hmm. Well, yeah, that's a good point. Do you have gas in both tanks?
Well, what about jumping that little thing that makes the fuel, jumping the relay to where the fuel pump runs at all times?
Well, that's not a bad idea. What do we have on a Ford that we don't have on any? Well, we got it on some toy, the inertia switch, right? Now, we stopped for fuel and it wouldn't restart.
So we were running then.
We were running. We drove at 40 miles. We drove at 40 miles. We stopped, put gas in it. That answers your question about is there gas in it.
Yeah.
You know, and it wouldn't start. Starting fluid. That's why he's assuming that the fuel pumps ain't running. Now, if he's got a switch on the dash, that flops it back and forth. He can switch it from one pump to the other and it won't crank on either pump. See what I'm saying?
Well, what's our fuel pressure?
That's a good question. What is the fuel pressure? Well, he probably doesn't have any if, you know, he sprays starting fluid in there and it fires up.
But if he didn't have pressure, it would die down.
Well, it had pressure right up until he stopped. Ran fine.
Well, so he had pressure.
He had good pressure right up until he stopped. And now all of a sudden his pumps won't work.
What about a relay switch?
The relay possibly, I'm thinking maybe it's possible that he had an ant that got in his relay. You know, ant climbed up there. So what I did was I told him to pull the relay. I showed him where the relay was on the little schematic I drew him. And I showed him how the terminals were laid out. And I says, pull the relay out. Take your test light and hook it hot. Touch it to the normally open that goes to the pump and see if it lights that test light. If it does, then you got a good circuit all the way to your pump, technically. Now there's theoretically you could have a short to ground between the relay and the pump that would make that light up. But if that's the case, you're going to have popped a fuse or something, you know what I'm saying? So if you don't have power there, you know, the first place I'd go be the inertia switch. Make sure the inertia switch is not tripped and make sure that it's not internally burned out. You got me? But I keep going back to the fact that it was running just fine.
Yeah.
There was an expedition the other day that pulled in. And it was a 2003 model or something. Pulled in up here in front of the college and it quit just right there in the parking lot. And I went up there and it had a bad fuel pump relay. Now, relay, once it's closed, doesn't usually crap out on you while it's going. You'll switch it off and when you go to start it back up, you see. Now the relay very likely is what's wrong with his because of the fact that everything was just fine. Now if somebody, you know, got angry and slammed the door really, really hard and it was enough to pop the inertia switch, that's a possibility. But I want you to think about that kind of stuff. This is a real world problem. The guy emailed me this morning about it. I thought I'd hit you with that. But basically I put this little thing together for him to look at. It was on his truck. It shows him where the fuel pump relay is, shows him what the socket looks like, tells him what each terminal does. And this is a good exercise for me, trying to get somebody that doesn't know anything much to understand how they need to troubleshoot. He was just going to put a PCM on it, just because.
It's already talking because when you turn the switch, right, PCM is talking.
Yep, PCM, if it fire up, it's talking, yeah. All right. Now, on a no start situation, you know what you do in order, right? You're going to check and see if you got spark. You can do a couple of these slightly out of order, but first thing I'm going to check is spark. Do I have spark? Do I have spark or don't? If you want to, you can plug your scan tool in and see if it'll talk. You know what I mean? If your scan tool won't talk, you'll turn on your key and see if you got 5 volts at your TP sensor. If you ain't, and it may be that your PCM's not powered up. You see where I'm going? Now listen to me, because this is going to be important when you're doing your finals. Because I'm going to line a bunch of cars up out there and you're going to have to fix a bunch of cars, you know, to tell me what's going on there with them. Got me? And so if I line them up and you got a certain number of minutes on each car to start working toward a solution, you're going to have to do it like 6 cars. You know, I want you to go away from here saying, gosh, I can't believe what he made us do for finals. You know, I mean, that's what other people need to hear. He made us do stuff for finals that, you know, it blew me away what I was having to do to pass this final. You also feel like when you pass the final, if you do, that you've accomplished something, right? All right. Let's jump into this electrical test. We're going to try to do these really quick and get them out of the way. But we're just trying to teach you how to think the right way. Do y'all like to think? Y'all like being able to think the right way? I get everybody signed in. Did everybody sign in? You need to make sure you sign in, because sometimes if I don't remember if you were here or not and you didn't sign in, I mark you absent. And that's not good, right? Number 1, a photocell uses light to change resistance. Number 2, modern automatic headlight dimming systems use rheostats to control beam switching. No. You need no rheostat to switch the beams. 3, if the park and brake is applied while the engine running, the daytime running light feature is turned off. And that is true. And we're talking GM cars typically. You know, the ones in pickup trucks, when you back out there and they turn on the lights when you're in drive. Illuminated entry systems turn on the courtesy lights after the doors are opened. No. After the doors are open? Now, that's a sort of a crazy question, because some of your illuminated entry systems, when you pulled up on the door handle, the light would come on. But they stopped doing that. And they went to the point to where you had to actually have the doors open before those lights would come on. And then when you close it, they stay on until you start the car. Why did they stop doing it where you pull up a door handle and the lights come on? What do you think? Yeah, they pull up on the door handle and they see your box of 8-track tapes in there. They're liable to steal. Oh, I'm dating myself. That was in the 70s.
So then why is that statement not true?
Well, they said it wasn't true. I don't know what his reasoning is. You know what I'm saying? If I would actually look at that illuminated entry system, turn on the courtesy lights after the doors are open, they'll also do it when you hit your fob. See what I'm saying? All right. Number 5, the adaptive headlight system automatically switches between the high and low beam headlights. Adaptive headlight system? No, that one don't do that. Okay. Number 6, Technician A says when a fiber optic indicator is not operating, the cause could be a bend in the cable. Technician B says the cause could be the light source not operating. Who's correct about that? B.
B only?
That's B only on that one. You know, the first vehicle I ever saw fiber optic dash lights on, you know, like all the knobs on the dash where the words were lit up by fiber optics, was a 74 International Lodestar 1800. It had one little teeny bulb in a little thing. It looked like a flying saucer mounted up under the dash. And there was optic fibers going to every one of the buttons. I mean, the knobs and stuff on the dash. That one light lit up every light on that whole dash. And that was in 74. They were using optic fibers to do that. Technician A says if the ignition switch is placed in the run position before the timer circuit turns off the interior lights, the timer sequence is shut off and the interior lights turn off. Now, if you've ever driven a car that's set up with that, you'll know about that. Technician B says a switch in the handle will close the ground path from the actuator when either of the front door handles is lifted. That's a sort of a dumb thing there. I don't even like that, but I don't like that question. But A is the right answer on that one. Technician A says solid state circuitry is used in headlight dimming systems to control beam switching. Technician B says headlight dimming systems use mechanical relays to control beam switching. That's Charlie. Nowadays, there was a time, who was it that put that dimmer switch on that pickup the other day in the floorboard? Was that you? That was when the switch was actually carrying the load of the lights, right? When the switch was carrying the load. Nowadays, you've got that multifunction switch on the side of on the stalk, and in a lot of cases, it's actually got a signal. It's operated kind of like a TP sensor. It's got resistors in there, and it deflects the voltage on that. There's a line coming from that body computer. It deflects that voltage a little bit by partially shunting that to ground. And whenever that voltage is measured inside that module, the module has an algorithm typed into its little microprocessor that tells it to send a request to change the state of the headlights. And it uses relays to do it. I mean, it's just a sort of a generic way of describing that. And I remember, some of you guys might remember me talking about this Grand Cherokee that had blinking high beam indicator. Blink, blink, blink. It's blinking off and on. Some kind of a binary code or something. It's really weird. So I called the hotline because there was nothing in the book about that. I couldn't see nothing on the scan tool. And they said, put a cluster in it. So I put a $600 instrument cluster in it. Of course, Chrysler was paying for it. Didn't change a dadgum thing. And it turned out it was the body controller. Because on that one, whenever you pull on that stalk, the body controller is actually getting that signal. And the body controller changes from low to high beam. And then it also sends a request to the instrument cluster. And it asks the instrument cluster to turn on the high beam indicator. See, so all of that stuff is going. And I was talking to somebody the other day about how when you push that button on the end of your stalk on one of these Fords, and it's got that little overdrive light. Was that you? Who was that I was talking to? You push that button, it doesn't turn on that light. It sends a signal to one of the pins on the engine controller, and the engine controller in turn reels back up that stalk and turns the light on. So it goes all the way to the engine controller and all the way back up on PCM, you know. And so that you're actually operating it's a little input of the computer, and the light's an output from the computer, but that switch does not turn that light on. The computer turns the light on based on input from the switch. And the wiring loop is about 4 or 5 feet long. But it happens instantaneously, and so you think you're doing it, you know.
It shifts instantaneously too.
It does. Yeah, it was because the PCM actually is instantaneously responding to your. Technician A says fiber optics provide illumination of several objects by a single light source. Technician B says light rays travel through the plastic strands by means of external reflections. Please, that's A. Technician A says to determine the illumination level of the instrument panel lights, the body computer uses inputs from panel dimming control and photocell. Technician B says using the body computer to control many of the lighting circuits reduces the amount of wiring required. That's C. Both those guys are right. The headlamp doors of a vehicle equipped with computer-controlled concealed headlamps will open but will not close. Technician A says the actuator motor may have an open winding. Technician B says motor brushes may be faulty. And that's going to be D, neither A nor B. There was some kind of a car, and I think it was some kind of little Toyota car one day, that somebody pulled up out in front of, out there by the right up here in the Ford dealership, and it had those little hideaway headlights on it. And they were going, it's flopping open and closed. It's different, not together, but they were just flopping and flopping and flopping. That was funny as all get out. I mean, just to look at that happen, you know. But my 69 LTD had vacuum operated hideaway headlights. And you could actually turn a knob and they go shh if you wanted them to be open all the time, you know. Hideaway headlights used to be a big deal, you know, back in the late 60s, early 70s. All right. Let's see. Technician A says fiber optics is the transmission of light through several plastic strands that are sheathed by polymer. Technician B says fiber optics cannot be used for automotive applications. That's A. Which of the following is true of the LED? It produces a red, green, or yellow light. It contains an anode. It requires an external light source. All of the above. Yeah. Well, wait a minute. That's the A is the only one. Yeah. But actually, one of the leads is an anode, and the other was cathode. But it doesn't contain. It doesn't only contain an anode. So basically, A is the right answer on that one. I was just reading the answers. Is what I was doing. A lamp outage module provides power to which lights?
Stoplights?
Yeah, well, this thing says all of the above, and that may be true somewhat, but some of the lamp outage modules I'm familiar with, or I was familiar with when I was working in the field, only fed the tail lights. And basically, it's got a little box with a little shunt going through there, and it's measuring voltage drop across that shunt, one of them lights. And if you got a bulb that's blown, and that voltage drop goes away, it knows there's no current flow in it, so it's measuring current flow. And if there's no current flow in it, knows that light's out. Something else that causes issues on one, well, like, you know, your cruise control, I was explaining to Daniel one day that the cruise control is looking for a ground coming through the stoplight bulbs, and when that ground goes away, when you mash the brake, it knows you mashed the brake. It's not looking for voltage, it's looking for that ground. If somebody puts LED tail lights on there, the cruise control may not work because it doesn't get enough of a ground through those lights, you see. And once again, and I've said this before, don't modify cruise control or airbags or none of that stuff, because there's serious implications to that. You know, if all of a sudden something goes south and, you know, blows up in their face, all of a sudden, well, you know, what's up with this? Well, somebody modified my cruise control so it would work with these lights right here, and that goes bad, and all of a sudden they, you know, my buddy Mark Shipes was driving his Jeep Cherokee one day, and they said the cruise control won't cancel. He goes, well, you know, I got to check see if this will happen. So he drives it around, and that Jeep, I'm gonna tell you, that 4-liter Jeep Cherokee, when it's in its power curve, you won't stop it with the brakes. I mean, that engine is a hoss. Anyway, he's over here on the traffic circle, and he stopped. Every time he stopped, it canceled the cruise. Well, he's coming down to the traffic to that stoplight down there by the mall, and he taps the brakes, and it didn't cancel. Slowed down a little bit, gave a little more gas. And then he just sort of panicked, you know, and he hit the brakes a little harder, and hit the brakes a little harder, and the cruise control module says, I don't see any cancellation, and we seem to be slowing down, so I think I'll just apply more throttle. And he was standing with both of his big muscle-bound legs on the brake, and this thing's doing a burnout out on the traffic circle. This smoke blowing out, scared the daylights out of him. Before, you know, you just can't think quick enough when there's cars down there and you're trying to stop. He didn't crash, but man, he came back white as a sheet, scared to death. Whoo! You know, I had one at the throttle. They said the throttle's sticking. and it was a Thunderbird Turbo Coupe, and I said, well, some smart aleck probably got a ticket, and they claim the throttle stuck or something like that. So I drove it, and finally I just punched it really hard at the floor, and it stuck under the doggone floor mat. And you're sitting there saying, whoa, this thing's in full turbo boost, and it's heading off up toward Ozark, and I'm saying, oh no, what am I going to do? You switch it off or whatever. Okay, let me see. Technician A says the light should turn off after a selected amount of time delay when a bright light is shown into the photocell. Technician B says the headlight should turn on within 10 seconds when the photocell is covered with the ignition switch in the run position. Now, who's right about that? That's actually C, pretty much. You got to be patient, though, because this thing is not going to happen instantaneously. Always a timeout. Always a timeout. Now, on some of these Fords, you can get in there to that little module, back when they used to have that little module, and they'd have a little hole in there, and there would be a potentiometer in that hole, and you could adjust that thing for different light levels. It was pretty cool, but it wasn't in the book anywhere. But if you looked in there, you could see that, and we used to have to go in there and adjust them. Although that's not, I don't even think it's like that anymore. Let's see. All of the following are precautions to prevent static electricity damage, except what? Wipe the terminals clean before installing the component is really not going to do anything to help you with static. You know how much electricity jumps out of your finger when that static pops? 8 to 25,000 volts is how much jumping out of your finger. You know what I mean? Whenever you shuffle your feet on the carpet and your wife is over there and you touch her on the ear and she likes, wants to slap the taste out of your mouth, all that stuff, pow, But that's 8 to 25,000 volts, and that will cook a microprocessor, do something, make it, bell. Okay. Let's see. Technician A says the lamp outage module is a current measuring diode. Technician B says the lamp outage module contains a set of resistors wired in parallel. Who's right about that? That's D, neither A nor B. The low-beam headlamps of a vehicle equipped with the Twilight Sentinel automatic headlamp system are inoperative. The high-beam headlamps are working right. The voltmeter connected across the low-beam contacts of the dimmer switch indicates the 12 volts when the low beams are turned on. Technician A says the circuit from the Sentinel amplifier to the dimmer is okay. Technician B says the dimmer switch is faulty. I was going too fast for you, wasn't I? Everybody lost on that? That's C, basically. Alright, let's look at 19. A vehicle equipped with a body control module has 2 fault codes stored in memory, B1445 and B1446. And those are body codes. After the codes are cleared, the vehicle is driven 2 blocks and the BCM is retested for fault codes. This time, only code B1446 is cleared in memory. Now, this is a technique that you guys all need to learn. When you're pulling a bunch of codes, let's say you go out here and you're checking a car, whatever kind of code you're pulling, you pull a wad of codes. You pull, 6, 8, 9 codes, or maybe 2 or 3 codes, or something like that. Write those codes down. Make sure you wrote them down right. Put them somewhere where you can keep them. I don't even like trusting a scan tool to save them for me. I write them down, or put them in my phone or something. So I'll know what they were. Clear them, drive it, and see if they come back. Because you don't want trash codes causing you to waste your diagnostic time. You got me? Clear them, see what comes back. You fix the one that comes back first. And then you're going to drive and see if some other ones come back. Or you may be able to parse and figure out, well, this one here calls that one, and so on and so forth, right? All right, so anyway, 19. After the codes are cleared, the vehicle driven in 2 blocks, and then the BCM is retested for false codes. This time, only code B1446 is stored in memory. Which of the following statements is true? What do you think, guys? C, actually, B1445 is history code. B1446 is the current code. So a history code is something it saw that's not there now. Current code is something that's wrong all the time. As a matter of fact, Ford will call that continuous monitor, or continuous codes versus on demand. On demand codes is I'm going to look right now, I see something wrong. Continuous codes mean I saw something wrong and I put it in the folder, but it ain't wrong now. Or certain conditions have to be met before the code is stored, and this kind of stuff, you see. Daylight running lamp systems are being discussed. Technician A says the reduced intensity of the headlamps can be accomplished by increasing the duty cycle of the power feed circuit. Technician B says on some systems the brightness of the lamps will increase as night approaches. That's basically going to be B. But I will tell you this, on them GM vehicles, like so many of them pickup trucks, they don't even use the same lights. Some of them use the headlamps for daytime running lights, and they'll have resistors in there, or they'll have a module that basically has a duty cycle. They don't want them as bright as regular headlights. But what are daytime running lights good for anyway? What are they there for? Anybody know? They're required in Canada.
Rain, tunnels.
No, it's just safety.
So that other cars can see you. It's not so you can see other cars, it's so other cars can see you.
Yeah.
They want to know, if those lights are on, you know a car's coming. but they may not even see you without the cars coming. Have you ever been driving? I was driving one time. I was trying to in a heavy rainstorm, and I was going to change lanes, and somebody just got on their horn. And when I got to analyzing this situation, there was a white Toyota pickup right in my blind spot with no headlights on, in the rain, in a heavy rain. How am I supposed to see this knothead? He didn't have his lights on, and he was acting like he was all indignant. Furthermore, he's riding in my blind spot. You know what I mean? Don't ride in somebody's blind spot, because it looks to you, they're real comfortable because you can see them, but they can't see you, and they're liable to change lanes on you and don't even know you're there. So you need to be riding somewhere else besides that blind spot, especially if you're on a motorcycle.
Especially,
Yeah.
yes.
You may have to lay that thing down, didn't you? All right. Let me see here. Let's see. The interior lights of a vehicle equipped with an illuminated entry system stay on even after the ignition switch is placed on. After a short interval, the lights turn off. Technician A says the input signal from the ignition switch may be open. Technician B says the entry module may be faulty.
None.
Now, that's going to be Charlie, actually.
What?
Yeah, it's possible. Think about it. If it don't know that it's been turned on, it's not going to turn the lights off. Another thing that's interesting, too, some of these vehicles, even that little silly Ranger, if I open the doors on it and I leave them open all night long, is my battery going to be dead tomorrow morning? No. It's going to kill those lights after 45 minutes because it's got battery saver. Got me? A lot of these cars got battery saver. They'll turn off the inside lights even if you leave them on. After about 45 minutes, they shut down. They got a little battery saver relay. They've also got delayed accessory. Now, most everybody in here has driven a car that whenever you park it for a little while, you can fool with the windows and play the radio until you open the door.
Yeah.
You ever seen that? That's the delayed accessory. General Motors calls that retained accessory power. And there's a module for it. It's called a wrap module. Ford's got a wrap module, but it's called remote anti-theft personality. So both of them have wrap modules, but they do different things. You know?
So accessories run off a fuse, man.
The accessories on these new vehicles, like I'm talking about, have a relay operating them.
Okay, because I don't have an accessory. I have one, but it doesn't work on my truck. Never had it.
What do you mean?
Well, it used to.
You mean
You know how you turn the switch all the way back?
Well, it may be timed wrong, so you can't get it on accessory or something like that. Somebody's put a lock cylinder or some worked on the steering column. If they got that thing slightly out of time, like the gear that goes down there, that's possible. But I mean, there's a couple of things you can do on that, or it may have an ignition switch issue or something. Aftermarket ignition switches are weird. There's a little ground wire going to the ignition switch so that when you turn it to start, it can prove out the temperature lights and all that kind of stuff. We put an ignition switch on a lady's truck here on one of those old Ford Rangers that came from the parts house, and as soon as we turned it on, it shorted out internally and it burned that little ground wire up and filled the whole truck up with smoke. Scared the daylights out of all of us. But one little piece of wire that long filled the whole truck up with smoke, you know. But anyway, sometimes there's a lot of times you can get an aftermarket ignition switch, but just be looking for stuff like that in case you have a problem. You know, we need to be careful about that. All right, let me see.
22.
A lamp outage warning system is indicating lamp failure. All the vehicle lamps are working, but one of them appears to be dimmer than the rest. Technician A says the light bulb may be mismatched. Technician B says excessive current resistance may exist in the right rear taillight circuit. What do you think about that?
Yes.
Who's correct about that? It's going to be 22. It's going to be A.
Yes.
Although I don't really understand why he said A on that. All the vehicle lamps are working, but one of them appears dimmer than the rest. That's A. Maybe mismatched. But I would say go ahead and put A because that's what he wanted you to put. And that's what the answer key said, but I don't like that answer. I think I'd really go with both of them because you can have excessive resistance in there and it will still show you on a lot of them systems lamp outage. Technician, or the wrong bulb can too. Technician A says photocell should be replaced if the lights don't turn off on within 60 seconds when the resistance assembly switches in the off position and the ignition switches and run. Technician B says the photocell should be replaced if the lights turn off within 60 seconds. Blah, blah, blah. What a stupid question. That's D, neither A nor B. What input does a body computer use to determine the illumination level of the instrument panel lights? Photocell and panel dimming control, which would be your little, most of those, they used to be a rheostat that actually pulled the lights, but now it's basically a little potentiometer thing on a lot of them. It changes the value at the body computer. What causes a photocell to change resistance values? I'm not talking about
Light.
Yeah, just light, that's all. In some illuminated entry systems, what sensor signals the body computer that the courtesy lights are not required? The photocell, come on. 27, and as ambient light levels increase, what will happen to the photocell's resistance? Going to increase. It's going to increase. Now, I don't like that either, really. because some of them that I've seen actually go the other way, but we'll leave that alone. On an automatic dimming, what sets the sensitivity at which the photocell and amplifier are energized? The sensitivity control. Computer receive inputs from which switches on body computer controlled concealed headlights?
Run that third thing again.
On body controlled computer concealed headlights. On body computer controlled concealed headlights, the computer receives inputs from which switches? Headlight and flash to pass. Headlight and flash to pass. What type of signal does the body computer use to dim the panel lights? A pulse width modulation signal. You guys remember what that is, don't you? If it's 100%, it's on all the time. If it's 50%, it's on half the time. The body computer uses inputs from what to determine the illumination level of the instrument panel lights?
Photocell.
Yes, panel dimmer and control of photocell. I think I got questions on there twice. What forward-facing input device does a smart beam system use? A 5,000 pixel digital camera. And then finally, we have all our essay questions. I know you guys love these. Explain the operation of automatic headlight dimming. Oncoming vehicles actually have the light from oncoming vehicles hit the photocell amplifier, and that changes it. You know, that's not too hard to figure out. I had a Chrysler one time, 67 Chrysler I was driving. It had a thing on the dash that looked like a ray gun, and that was supposed to be a headlight dimmer. And there was a big truck coming along there one day, and that thing turned the lights on, off, on, off, on, off, and then it turned them off. I mean, it dimmed them and brightened them several times, then turned them off, and I unhooked that darn thing. I do not want nothing turning my headlights off when I'm going down the road. But that was in 67 when they weren't that good at building electronics. You don't have that problem nowadays. Not that I know of. Let's see. Let's see, number 5. What are the major components of an automatic headlight system? What do we got, guys? Somebody talk to me.
Photocell.
We got a photocell, got an amplifier, got an ignition switch, got a headlight switch. Can you hear me?
Photocell.
Yep. All right. Describe the function of an instrument panel dimming system. Anybody got that? BCM receives input from the panel dimming control, photocell and a photocell to determine the illumination level of panel lights. See if it's really bright outside, or brighter than normal, you'd have brighter panel lights and all this. Kind of like on your TVs. Who in here's got an LED or LCD TV that changes according to ambient light in the room? You ever seen that? Or did you even read the instructions?
Oh, yeah. Samsung.
Yeah, I got mine's a different brand than that, but it actually, the brighter it is in the room, the brighter the TV lights up. That's an energy saving thing, I guess. Number 37, explain the function of illuminated entry. Provides activation of the courtesy lights before you open the doors. Allow them to remain on after the door is closed until the ignition is turned on and the system times out. Now, like I say, you're going to typically be doing a fob thing there. They've done away with this pull up on the handle deal, pretty much. Describe a lamp outage module. What kind of a sensor is it?
It measures amperage.
It's a current measuring sensor. Yeah, exactly. You're right. You probably read that in the chapter, didn't you? It's got a set of resistors wired to series in it. The BCM receives input signals from the headlight switch and controls and monitors the lights using relays or lamp drivers. Number 39 that's basically the answer to 39. Tip computer controlled headlight system. And finally, explain the function of automatic headlight timer control. Controls the automatic operation of the system, length of time the headlights stay on after the ignition switch is turned off. We just kind of blew through those in a big hurry. Okay. Alrighty.